Laten wij, met u goed vinden, nu terugkeren naar overigens niet minder interessante aardse zaken. In de Noordzee, oppervlakte 18 maal Nederland, gemiddelde diepte 90 meter, zwemmen op dit moment 30 soorten walvissen en dolfijnen en 170 soorten vissen rond. Maar zouden wij nu 300 miljoen jaar geleden hebben geleefd, dan hadden deze dieren waarschijnlijk pootjes gehad en zouden zij bij inspanning flink hebben getranspireerd. Ooit was de Noordzee immers geen zee en lag de Noordzee niet in het noorden. Dat heeft te maken met de theorie der zogenaamde schuivende continenten. Deze theorie werd zo'n 1,5 eeuw geleden voor het eerst geopperd en het bewijs ervoor is onlangs geleverd. De geoloog uit Wales, Kees James, wiens naamkaartje de titels MSc, PhD, FGS vermeldt, employee bij een multinational in gas en olie, heeft het bewijs bij boringen in de Noordzee boven water zien komen. Noorderlicht nu aan de Noordzee.
Het booreiland Triton is enige weken geleden van Rotterdam naar de kust voor Kijkduin gesleept. Dit geschiedde in opdracht van de Nederlandse aardoliemaatschappij, die hier op 3800 meter uit de kust proefboringen gaat verrichten. Het is de eerste van een serie proefboringen. Het volgend voorjaar gaat men ook op andere plaatsen in de Noordzee aan de gang. Het boorgat wordt voortdurend gespoeld. Met deze spoeling komt het boorgruis mee naar boven. Uit dit gruis kan men de samenstelling van de bodemlagen afleiden.
I think the art is being able to look at what's happening around you today and then being able to see those same processes written in rocks and being able to imagine how those processes took place in immense periods of time before we came to exist on this planet. Beneath our feet, here at the side of the North Sea, and out there beneath the sea itself, hundreds of meters down, there is a thick layer of salt, some hundreds of meters thick. Beneath that layer of salt, there's a layer of sandstone. And beneath that again, there are layers of coal. Now we are talking about 2,000 to 3,000 meters below the surface of the Earth. The coals formed somewhat in the region of 300 to 325 million years ago, followed by the sands, something in the order of 270 to 300 million years ago, and around about 250 million years ago, the salt. Imagine the Earth 300 million years ago, 300 to 325 million years. Here is the equator, and we know that today coals form in swamps in this sort of latitude, in equatorial tropical latitudes.
So that stone comes from the equator?
Well, it was deposited in this sort of latitude.
And then what happened next?
But then we come to the deposition of these sand dunes laid down in deserts, and we believe that by that time we are talking about latitudes slightly further to the north.
And the salt?
The salt. The salt was deposited in a sea which became which dried up. We believe that what happened was that at this time Europe was moving towards the north. That story we work out by saying that first of all we were depositing coals in tropical latitudes, and then we moved northwards into a desert environment here. But while Europe was moving towards the north, Africa also was moving towards the north and collided with Europe, raising a mountain chain and forming a depression in which the desert formed. The desert, we think, formed probably below sea level, and as the sea level rose, the sea invaded that basin, drowning the desert, forming a sea, but the link between the oceans and that sea was broken, so that the sea became isolated, evaporated and precipitated all its salt, leaving just this layer of salt behind.
The continent in its whole is moving up, and all this has been the surface of the Earth.
Exactly.
It's possible to calculate how fast this part of the world has been moving.
We can make an approximate calculation by assuming that if what we believe is true, that these rocks formed at the equator, 0 degrees, 300 million years ago, and today we find ourselves here in the North Sea at 55 degrees north, then we can try a calculation. So 55 degrees as part of 360 for the whole Earth. The circumference of the Earth approximately 40,000 kilometers. Which is another 3 knots to take it into meters. 2 knots to make centimeters. We have to divide that by 300 million years. We are left with 40 over 3, which cross off this one here. 4 into 36 goes, that's 9. 9 times 3, 27. 27 into 55, about 2 centimeters a year.
It's not a fairy tale, you call it.
No fairy tale, no fairy tale.
Science.
It's science, yes, and in geology, science combined with imagination, a little bit of art if you like. Looking at data from the oceans, looking at data from all parts of the world, in the way that we looked at the rocks from the North Sea today, this data allows us to put together a very complex picture, but painstakingly, as you see here on a computer, we can model the changing positions of the continents through time. So we arrive at the concept that the continents are moving, the theory of continental drift. This theory is not new. As long ago as over 100 years ago, people recognized that this part, South America, fitted perhaps neatly into this part of Africa, that North America perhaps could be brought and fitted in here to make one large supercontinent called Pangaea. It was a theory that was not accepted for decades. People who proposed this theory had a lot of opposition. It has been given a great deal more support during perhaps the last 30 years when sophisticated scientific technology that allowed us to look at the structure of the oceans, to see how the oceans have grown. That shows us indeed that the oceans have spread apart. But the further back in time we go, then the less confident we are. But the picture continues to evolve. We think indeed it is still moving. Now we have satellites that tell us that relative to each other, the continents are moving.
And in about 100 of millions of years?
That's looking too far ahead. What's likely in such a period of time is that continents will have moved far enough to have collided perhaps and created new mountains, and then perhaps having welded into one large continent begin to break up and drift off in different directions.